Hi, in continuation with the previous video, now we are going to discuss about the comparison of analog sensors versus digital sensors. The analog sensors, the output is a continuous function or it depends on one or more of its input parameters. But digital sensor has a binary based response. And the digital sensors produces a discrete digital voltage or signal that is considered to be a digital representation of the measurement, that is a binary measurement. And the sensor will display binary output, means it displays the ones and zeros as the output. And the digital sensor tend to be considerably less expensive when compared to analog ones. So the analog sensors costliest one. These sensors are known to have a fast transmission rate as well as a negligible distortion. They don't have the same limitations as analog sensors because analog sensors gives the maximum limit range, but the digital sensor does not have the maximum digital range. And used to measure the pH level, ammonium concentration, nitrate concentration and dissolved oxygen. And if we compare the analog sensors versus digital sensors with some factors, first we see about the data transmission as one of the parameter. And analog sensors, it includes the deterioration by noise, and the digital sensors, the noise immune without a deterioration. Signal, it is a continuous signal, we know that it is representing a physical measurement. The digital signal representing discrete time signals generated by digital modulation. And the next one is the bandwidth. The analog sensors produces the output in a lower bandwidth itself, and the digital sensor produces a higher bandwidth. And the power which is used by analog signals takes larger power, and the digital sensor consumes a less power, and also it is a negligible power also. And the waves, the output waves produced by the analog sensors are sine waves, and because it is a continuous signal, and the digital signal produces a waves as a square waves, and because it is a binary values. And the next parameter is the impedance value, and the impedance is low. Here the impedance, it produces a high impedance order of 100 mega ohms. And errors, it gives the observational error occurs because we are going to measure the analog signals in a order, and it will produce us a value, so it will free from observational error. And the applications of digital sensors, includes so many industries and so many applications. And water and industrial process are the most common applications for digital sensors. And also pH measurement, redox potential measurement, conductivity measurement, and also used to measure the dissolved oxygen, ammonium nitrate and SAC and some other. These are implemented in cell phones and other internet connected devices. In game controllers and computer components also, so many digital sensors are used. And the digital sensors are used in healthcare profession also. And the personal navigation equipment is also equipped with this technology. And if we consider for applications of analog sensors, the analog sensors, we know that it is mostly used in speakers, ultrasonic distance sensors. It is used to measure the distance between the two objects, and the light sensors, ultraviolet light sensors, flux sensors, transistors, and the force sensitive sensors are also coming under the category of analog sensors. The next is about the inductive sensor. An inductive sensor is an electronic device that can detect ferrous metal targets without physical contact. The inductive sensor will also detect a non-ferrous metal targets like aluminium, brass and copper. But using non-ferrous metal targets decreases an inductive sensor sensing range. And the main parts of the inductive sensors are the first one is the cable end, the indicator light, sensor's body, sensor's face. The four major components that are present in the inductive sensor parts. And the types of inductive sensors based on the configurations, it is divided into AC or DC inductive sensors, shielded or unshielded inductive sensors, and normally open or normally closed inductive sensors. And based on the transistors, it is classified into NPN or PNP inductive sensors. Thank you.